Hi everyone, this is coming to you from Education for All. We are now solving our problem number 3. Problem number 3 says prove that the limit x squared as x tends to 2 or x approaches to 2 is equals to 9. Is that it? Sorry, is that x approaches to 2? No. It should be 4. X approaches to 3. Yeah? So looking at it intuitively, it's very simple to solve. How? You know, if x is 3, so 3 squared gives you 9. Agree? If you replace x by 3, so 3 squared, 3 times 3, you get 9. Intuitively, it's easy to solve. But we do these proofs in a rigorous manner so that they can be applicable to a wide range of fields. So to prove it rigorously, we will state that for all epsilon, for all epsilon greater than 0, there exists delta greater than 0 such that the absolute value of x minus 3 is less than delta, which implies that the absolute value of x squared minus 9 is less than epsilon. So that is the rigorous statement to prove it. For all epsilon greater than 0, there exists delta greater than 0, such that the absolute value of this distance is less than delta. That implies the absolute value of the distance on the vertical axis minus the limit is less than epsilon. Recording? Yes. So now, how do you go about it? You now know that for delta greater than 0, we have x squared minus 9 is less than epsilon. Right? Even it's there already. So that is what we got. X squared minus 9 is less than epsilon. You always use epsilon to find delta for these proofs because epsilon is given to you, or it can easily be found from the function. Epsilon can easily be calculated. What is difficult to calculate is the delta, because epsilon is like the output. You are given the output and you want to find the input. Most cases they give you input. If equations, you feed in normal equations, you feed in the input, it spits out the output. But in this case here, you are given the output and then you work out what the input is. That is why the proofs of epsilon delta, definition of limit, the proofs go reverse way because of the way the question is given. Given inputs, I give you inputs. Now I give you outputs. Give me the inputs. That's how it goes. I give you the answer. Give me the problem. So this is how these proofs are done for a limit. Right? So now you have that one. For delta greater than 0, x minus 9, the absolute value of x minus 9 is less than epsilon. So this implies that x plus 3 and x minus 3 less than epsilon. Agree? The difference of two squares. What we have, let me explain it so that you can understand it. You have x plus 3, x minus 3 less than epsilon. Agree? These are absolute values. So when you have a multiplication of absolute values, if you have A times B, you are also allowed to state it as this is allowed, right? So this is what we just did earlier on. So this will give you x plus 3 absolute value and x minus 3 absolute value less than epsilon. Okay? So then we know x minus 3, the absolute value of x minus 3 is less than delta. Yeah? So this will give us x minus 3 is less than epsilon divided by x plus 3. Agree? We just divided by x plus 3. That's all what we have done. So now we let delta, because here we know delta is this value, x minus 3. So now we can say delta is less than epsilon x plus 3. Delta is less than epsilon x minus 3. Correct? So what do we do next? What do we do next? We need to find something for x minus 3. This is slightly different. I want to move fast so that I don't want to make this video too long. It's slightly different from the previous ones. Once you arrive here, this one, because what we have is x minus 3. So that is what we are looking to work out. So we assume x minus 3, the absolute value of x minus 3. Now, we assume that this is less than 1. before we say it's less than delta. We don't want to go too far. You can put 2 is okay, 3 is okay, but normally 1 is preferable. So it doesn't really matter what number you put there. At the end of the day, it's going to work out nicely, but 1 is preferable. So when you have an equation like this, what it's telling you is, in fact, if this is less than 1, then you are saying that minus 1 is less than x minus 3 less than 1. That is what that means. If you state it like this, this is what it means. This is how it is read. So let's do something here. Now I want to remove this 3 first. So if I remove this 3, if this is minus 3, if I want to leave 0 here, my target is to put x plus 3 inside here. But let's do it step by step. First, let me remove 3. If I remove, minus 3. If I remove minus 3, so this is going to be now plus 3 minus 1 less than. And this is now x. There is no more 3. Now it's 0. Yeah? And on this side, this is going to be 1 again plus 3. This is minus 3. Bring it here, it will be plus. Minus 3, bring it there, it will be plus as well. So it's going to be plus 3 minus 1 and 1 plus 3. So 3 minus 1, this gives you a 2 less than x greater than 4. Correct? I hope you follow. So I told you I want x plus 3 here. So if I add 3 here, if I had x plus 3 here, I'm going to add plus 3 here as well, and also 4 plus 3 here as well. So therefore here I'm going to have 5 less than x plus 3 less than 7. So this is what I want. I've changed it from x minus 3 to x plus 3. That is what you do for this sort of problems. Yeah? Because we have x plus 3 here. So we need to do something about it. Correct. So we now have x 5 less than x plus 3 and less than 7. But we want it to be a fraction, as it is a fraction here. Yeah? We want it to be a fraction. So if you divide everything by 1, let's say 1 all over x plus 3, we still have this thing. Now, everything will change when it goes to a fraction. We now have 1 divided by 7 and 1 divided by 5. This is how it will change, because 1 over 7 is less than 1 over 5. So you cannot have still 5 here and 7 here, because the fraction have changed everything. You know, 1 all over 7, 0 point, 0 point something. This is 0 0.2. Yeah? This is less than 0 0.2. So this is bigger than this. That's why it changes. I hope you understand that. So what do I want? Because I have epsilon here, I now want to multiply everything by epsilon. So then I will get epsilon all over 7 less than the absolute value of epsilon all over x plus 3 and less than epsilon all over 5. That's what I got. That's what I got. So now the proof. Now comes the proof. all what you have done to find a value for delta. Now comes the proof. And the proof will assume that epsilon is greater than 0. And the epsilon is greater than 0, we let epsilon greater than 0. And then we will find the minimum of 1 all over 7 and 1. Is it 1 over 7? Epsilon over 7. Epsilon over 7. Why am I writing? This is why this is epsilon, sorry. Epsilon all over 7 and 1. We'll find which one is smaller among the two. Yeah? You know, because we choose 1 before here to do our manipulation here. And we know epsilon over 7 is smaller than epsilon over 5. These two already know this is smaller. So we'll look for the smallest one. So which is epsilon over 7. So epsilon over 7, and what we did here, even to get this epsilon over 7, it was 1. So we now want to find the minimum of these two. The minimum is what we want to use in our proof. I hope this helps. I have to be fast so that this video will not go over 20 minutes. And we already said that x, the absolute value of x minus 3 is less than delta. Then, we already said this, absolute value x minus 3 is less than delta. Then, x minus 3, we are taking it from there, is less than now epsilon. Why am I writing epsilon like this? All over 7. We are taking the minimum of the two. We are assuming this is the minimum. Yeah? These two are taken. I told you we are going to take one. Which one is smaller? We're assuming this one, the one with the fraction, is smaller, because epsilon, we are talking about small, is error. When you start to solve proper problems, you will see that it's a Greek word, it means error. So errors are small, tiny numbers, right? So that is what we get. Then we have that. And we also know that x minus 3 is less than 1. We also know that x minus 3 is less than 1, which is here as well, which implies x plus 3. So this one implies, if we put 3 here, if we put plus 3 here, x plus 3 is less than 7, correct? X plus 3, yes, it's less than 7. Just work it out. Then x minus 3, then x squared minus 9. I hope you understand what we have done here. First, we added 3 to make it 0. Sorry, first we added 3. When you added 3, make it 0. And then you add another 3. Yeah? So when you add 3 here, it will make this will go 4. And then 0. When you add 3, now it will go 4 plus 3. That will make it 7. Right? X minus 9, we know what that means, epsilon. This gives us x plus 3 times x minus 3. We know that one already, which implies x minus x epsilon over 7, x plus 3, epsilon over 7, x plus 3. Where is it? Where is it? Correct. Epsilon over 7 times x minus 3 is 7. And all this boils down to epsilon because this cancels. So therefore, now you state your conclusion. X minus 3, x squared minus 9 is less than epsilon. So it's proven. I hope you follow the argument. Thank you for watching. Bye-bye.